general, we need local level information on how climate risks are going to change to support practical on the ground adaptation responses. And I'll get to how we might think about generating that local scale information later in the lecture. But first, I want to provide a broad brush picture of what's in store for Africa in terms of climate change. Now, the extent of climate change in Africa, first of all, depends on global scale processes. First of all, this global change itself depends on two main factors. First of all, what we call sensitivity, and second, future emissions. Now, sensitivity refers to a concept called climate sensitivity, which is the extent of warming that one would get globally for any particular increase in the concentration of greenhouse gases and other pollutants in the atmosphere. The problem is that the sensitivity of the climate system is not well constrained. We don't understand it that well, and that's because there are a number of feedbacks and other processes that can amplify the initial, what we call forcing of the climate system by greenhouse gases, and these themselves are not well understood. So a couple of examples of that include, for instance, heat uptake by oceans. So a large proportion of the warming that happens in the atmosphere because of greenhouse gases actually then gets taken up in the oceans. About 90% of all of the additional warming that we've seen is actually being absorbed in the oceans, and only 10% remains in the atmosphere. So in thinking about the future, if that heat uptake changes very slightly, then the temperature response in the atmosphere, which is where we feel it on the ground, might be larger if less heat is taken up by the oceans, or lower if more heat is taken up by the oceans. The second feedback and uncertainty is around the cycling of carbon between the atmosphere and the ocean and the land surface. And because we're uncertain about how carbon is stored and moved between these different parts of the climate system, we therefore are uncertain about what future concentrations of carbon dioxide might be from a given level of emissions. And then another example of a feedback that we're uncertain about is the role of clouds. So clouds both reflect and trap heat in the atmosphere, and how clouds change might change the balance between their reflective cooling effect and their absorbing heating effect. And so we don't really know whether climate change will then produce changes in clouds that add to extra warming or actually add to a cooling. So what this climate sensitivity means is that even if we know exactly what the future global emissions will be, the global and the regional climate response will have a range of possibilities because of these uncertainties. So for example, let's assume that the pledges from the Paris Agreement on climate change are actually implemented. If all those pledges are implemented, then emissions of greenhouse gases will peak at a number that's 53 gigatons of carbon dioxide per year in 2035, and then they'll decline year by year so that we're only emitting 40 gigatons per year at the end of the century. Even if we knew exactly what those emissions were, like this in this case, the uncertainty in the climate response means that we can only say that the amount of global warming from that specific emissions future would range between 2.3 and 3.5 degrees of global warming. And that's due to this uncertainty about climate sensitivity. But emissions in the future and the reductions in emissions that we might expect are also uncertain. We've really got no idea how effective climate policies will be. We also don't know how the global economy is going to evolve and how population is going to change. So all those factors that affect emissions in the future are also uncertain. What we do know is that we need fast and deep cuts to have any chance of keeping below the policy target of 2 degrees. And that what at the moment seems most likely is that we're only going to get moderate cuts or even a worse situation of business as usual or continuing on the current trajectory. If we combine our understanding of the uncertainty about climate sensitivity and our uncertainty about emissions, then we could probably say that a global warming of 2 degrees by the end of the century is possible if all the stars align, if we have all the climate policies coming into play, so we have those deep and early cuts, and the climate system itself has a relatively low sensitivity. So the warming per sort of unit increase in emissions is relatively low. We're more likely to be on track for a 4-degree global warming by the end of the century if we only have moderate cuts in emissions and if the climate system itself has a higher sensitivity. So at the moment, when we're thinking about the future for Africa, the best we can say is that in the second half of the century, the global temperature changes that we can expect or that we can't rule out probably vary somewhere between about 2 and 5 degrees. And that's the future that we have to plan for in the global context.